The normal distribution is a probability distribution that captures many natural phenomena, including phenomena related to random sampling, so it is one of the bedrock concepts in statistics. The normal distribution is derived from a mathematical formula. It is theoretical, in contrast to an empirical frequency distribution that is constructed from a dataset. However, many data sets show that natural variables like height, weight, IQ, along with many others, are approximately normally distributed. Here you can see that the variables height, the corneal pressure of human eyes, the compressive strength of concrete, and a measure of empathy are all approximately normally distributed. Remember sampling errors? The difference between a population parameter and the estimate of that parameter we get by sampling from that population? Those sampling errors are also often normally distributed. Because the normal distribution is observed in these and many other situations, it is a central concept in statistics. As shown here, normal distributions have a particular shape, but there is some variation. Some are wide and short and others are narrow and tall. These are all normal distributions. All normal distributions share two features, which are illustrated here. First, normal distributions are symmetrical around a center point equal to the mean, median, and mode of the distribution. Second, normal distributions are proportioned identically, which means that areas under corresponding regions of the curve are always identical proportions of the whole. The total area under the curve sums to 1. The peak of the curve is centered over the mean, median, and mode, which can be any value of the variable under consideration. In these graphs, the marks along the x-axis are units of standard deviations. The region between the mean and one standard deviation below or above the mean has an area that makes up about 34.1% of the total area under the distribution. The areas between 1 and 2 standard deviations below or above the mean each contain about 13.6% of the area under the curve. The total area between -2 standard deviations and +2 standard deviations contains a little more than 95% of the area under the curve. Because so many phenomena conform to a normal distribution when sampled in large quantities, and because normal distributions are consistent in their shape and proportions, these distributions provide a useful tool for summarizing data. Look again at the measure of empathy we showed earlier. The histogram is composed of results from 478 participants who all responded to a self-report test of empathy, Kim and Lee, 2010. The empathy measure ranged from 0 to 70, with 70 representing greater empathy. The mean for this data set is 35.44 and the standard deviation is 9.64. The results approximate a normal distribution, which allows us to infer the characteristics of the population from which the data were collected using the properties of the normal curve. For example, because the data approximate a normal distribution, we can infer that about 68% of the population, the mean plus or minus 1 standard deviation, will have an empathy score between about 26 and 45. And figuring plus or minus 2 standard deviations, we can expect that about 95% of the population will have an empathy score between 16 and 55. We also know that only about 2% of the population will have scores below 16, or above 55.